Hello, I'm back, and this time I'm going to solve a question from the section 14.7, question 10, which asks to find the local max and local minimum, and if there exists saddle points of this function, which is 2 minus x to the power 4 plus 2x squared minus y squared. So we know the steps. Steps are first find critical points of the function, then use a second derivative test. Let's do the steps. Step 1 then, the critical points. Critical points. To find critical points, I find first partial derivative with respect to x and y, set them equal to 0, solve them. So fx, partial derivative with respect to x, is minus 4x cubed plus 4x, set it equal to 0. That's not enough. I have to do both first partial derivatives and then set them equal to 0, which is minus 2y with respect to y, set them equal to 0. This is an easy case, meaning that the equations are only in one of the variables. So for this one, I can solve it easily. Easily you can see that y is equal to 0. To solve this one, I can factor out x or negative x, and I get x squared minus 1 is equal to 0. And if you solve that, you get 0, 1, negative. Since there is no dependence between equations, then critical points are going to be the points for which we have these values of x and this value of the y. So the critical points are 0, 0, 0, okay, 1, 0, and negative 1, 0. So we're done with the critical points. Then time to use the second step, step 2, which is use the second derivative test, for which you can go back to your notes or your book and check that the first thing to do is form this function, which I'm going to do here. So d is fxx, second derivative, both of them with respect to x. So the first one I have here, I have to do the second one, minus 12x squared plus 4 times fyy, I have already one derivative, then another one, 2 minus fxy, so this one I have fx, I have to find the derivative of this guy with respect to y, there's no y there, and that means it's, then we can multiply, it's 24x squared minus 8. So that's my d. Now, to apply the second derivative test, I have to plug in my points in this d. So one by one, point 1, d0, 0. At 0, 0, I plug in x0, y equal to 0. I get negative 8, which is negative 1. Check the second derivative test in your book. If d is negative, then 0, 0 is a saddle point for f. So that's the first point. So 1, 0, I'm plugging in 1, 0 here. I get 24 minus 8 is 16. If d is positive, you have to go ahead and do another test, another part of the test, which is plug in your point in fxx. I already have x, which is fxx, which is this part. Plug in 1 here, I get minus 8. It is positive. If these, sorry, it is negative. If this is positive, fxx is negative, then the second derivative test says that f has a local maximum at that point, which is 1, 0, with value, just plug in 1, 0 in your function. So 1, 0 in our function. 0, this goes away. 2 minus 1 plus 2. It is equal to 3. So that's the second point. And the third point, plug in -1 for x, 0 for y in this, for d. So I get 24 minus 8, which is 16. It is positive. Again, second part of the function, second part of this, the second derivative test, which means that you plug in -1, 0 in the second derivative of f with respect to x, which is here, and it gives us -8 this time again. So it is -8 by the second derivative test. F has a local max at this point with value f -1, 0 equal to 3. So plug -1, 0 in the function, you get 3. So basically we did the second derivative test, find critical point, second derivative test, and we figured out that there is one saddle point, 2 local max for the function. Thank you.